Now that we know that protons and neutrons make up the mass of an atom, we can now define what atomic mass is. Now, atomic mass is defined as the mass of the atom in atomic mass units, or AMU. And what is an atomic mass unit? We define one atomic mass unit, or AMU. This is equal to 1/12 the mass of one carbon-12 atom. And the reason why we choose carbon-12 is that, by definition, carbon-12 has 6 protons and 6 neutrons. All right, now, if we look up the atomic mass of an element on the periodic table, the value is not 12.00, as the definition suggests, but 12.01 AMU. So what's going on here? Well, keep in mind that we've also got isotopes to deal with. Okay, so when we talk about an atomic mass that shows up on the periodic table, this atomic mass, this number, is actually a weighted average of all the naturally occurring isotopes. Okay, so for instance, you've got carbon-12, which has a mass of 12.000000 AMU, and this represents 98.90% of all the forms of carbon on Earth. You've also got an isotope of carbon-13 that represents 1.1%, which has a mass of 13.00335 AMU. And so we calculate the average mass as this way. So we say that the average mass would be equal to, we take the mass of carbon-12, so 12.00000 AMU, and we multiply it by its percent abundance. But we convert that percent abundance from a percentage, we write it as a decimal. So this would be 0.9890. Okay. We're going to do the same thing for carbon-13. So the mass of carbon-13 was 13.00335 AMU times that percentage, which is 0.0110%. So we do the multiplication and add up the two values together. And the number I get, when you do the math here, the number I get is 12.01104 AMU. And so usually carbon is either going to be written as 12.01 on the periodic table or 12.011 on the periodic table. So it depends on what you're looking at. But so that's how you get that atomic mass number. All right, so let's try a problem out. The atomic masses of two stable isotopes of boron, boron-10, which has an abundance of 19.78%, and then you have boron-11, which has a percent abundance of 80.22%, is 12.0129 AMU and 11.0093 AMU, respectively. Calculate the average atomic mass of boron. So we're going to do this the same way that we just did this last problem. So we're going to work with one isotope at a time. So let's take the isotope of boron-10. So the mass of boron-10 was 10.0129 AMU. And we multiply that by the percent abundance of boron-10, which is going to be 0.1978%. Okay. We're going to do the same thing for boron-11. The mass of boron-11 is 11.0093 AMU. And we multiply that by its percent abundance, which is going to be 80.22%, so 0.8022. And if we add up those two numbers together, we get 10.879356622. Now, how many numbers do we have to report this with? Usually we go out to three decimal places. So we would write this number, the final answer is 10.879 AMU. And so that's how you calculate the average atomic mass of an element.